Hi, it's Mrs. Thompson again. Welcome back. Today we're going to talk about symmetry in relations. So symmetry is, there are various types of symmetry. First of all, we can talk about symmetry about a line. Now this will just create a mirror image, like the image that we've got has been flipped across that line. We can talk about symmetry about a point, which will basically rotate the shape about that point. There are three specific ones we're going to talk about today, and that is when we flip it about the y-axis. So every point xy is going to get reflected across the y-axis to a negative x. Then we're going to flip it about the x-axis. So every point is going to get reflected to the new point of x negative y. And then we're going to rotate them around the origin. So every point will change to negative x, negative y. So let's see what we mean by that and how we can actually figure that out. First, let's look graphically. So on these graphs, if I were to pick some point here, I notice that that same exact point happens down here. Okay, so for specifically I have 4, 2, and I have 4, negative 2. But that happens to every point. It gets flipped. So this one would have symmetry about the x-axis. Okay. In this picture, if I pick some point, let's look, I've got 1, 1. I notice I also have negative 1, negative 1. So I took this point and I flipped it to where they were both negative. So this one has symmetry about the origin. Okay. So sometimes I can visualize these reflections and rotations, but sometimes I don't have the graph, or I'm not sure I have all of the graph, so I want to be able to actually look at this algebraically. So let's just take an equation and determine whether it has symmetry. So the three types we were looking at is that xy is going to equal the same point as negative x, y, or that it can result in x, negative y, or that it can result in negative x, negative y. So the first thing I'm going to do is I'm going to find out what happens when I plug in a negative x. So now I have 3 times negative x squared plus 2. So that's just still 3x squared plus 2, which is equal to y. So I got the point negative x, y. So that gave me a reflection about the y-axis. Okay, now let's see what happens if I put in, can I get to a negative y? Well, if I let y be negative, is there any way to do that? Well, squaring the x is always going to make this positive. I'm always going to end up back at positive y. So there's no other symmetry for this one. Now, just from the algebra standpoint, we know from maybe previous lessons that this is a parabola. So I can see that symmetry, that it has been reflected. And in other words, I could fold it in half, okay, along the y-axis. Okay, let's try another one. Again, let's put in a negative x and see what happens. So I'll have 2 times negative x squared plus 3 times y squared equals 1. Okay, so if I leave y alone, does this end up with exactly what I started with? Well, yes. Okay, what if I let just the y be negative? I still get it equaling 1. And what if I let them both be negative? Well, squaring things always results in a positive value, so I still get to 1. So this particular relation has symmetry about, the first one tells me about the x-axis, the next one tells me about the y-axis, excuse me, the origin, and then the last one tells me about the y. So I'm getting all 3 types because I got all 3 values working. Okay, so what this one actually draws, which what we will find later on, is that this one actually draws what we call an ellipse. So it looks like an oval. So you could see that I could fold it in half this way, and I could fold it in half this way, and as long as it's centered at the origin, then it could flip to the different quadrants as well. Okay, last one. This is a fraction, a rational equation. But again, I'm going to just try these different points. So if I plug in negative x, let's see what happens. Okay, these are my questions. So if I let x be negative, what I end up with is a negative on the top, but I end up with the same thing I started with on the bottom. So this ends up being a negative y. So negative x results in a negative y. So I get that reflection about the origin. Okay. All right, and the only way to get to that negative y would be to change that value of x. So if x stays positive, I'll never get a negative y. So this is only about the origin. Okay, and as we learn to graph these more, we'll be able to see the different types of symmetry as well. So hopefully you're going to join me next time, and we'll continue. We're actually going to move from relations into functions. But this should give you a good start on symmetry. So we'll see you next time.